Alright, we're going to talk about function generators, frequency generators. They're the same thing by a different name in oscilloscopes. And obviously a frequency generator or a function generator is something that's capable of creating a waveform. So we create these waveforms using this function or frequency generator device. Now we look at these waveforms using a scope. So kind of think of it in a sense like looking through a camera. If we're taking a picture of the Eiffel Tower is a fixed object. It doesn't change. But we can zoom in and out, and we can make the Eiffel Tower larger or smaller than what it appears to our eyes, perhaps. Well, this function generator is what creates the Eiffel Tower. It creates this waveform. And so if you look, this particular function generator is generating a 1 kilohertz waveform that's 100 millivolts in amplitude. Now, 1 kilohertz is its frequency. Excuse me. And the 100 millivolts is the amplitude of that. Now, I can change my view of it just by changing this time per division on here. And I can also change volts per division. And just like when I zoom in and out on an object with a camera, it can be larger than the screen can hold it. So we have to zoom back, and that's kind of what was happening there. We're merely changing our view of this waveform down here. Now we can use these knobs to change our waveform. I'm not going to do that because this is the one I've chosen, and you're going to have to choose a different one in a minute, and you're going to have to become a teacher and send me a picture of something that explains this waveform that you see here. So let's talk about how this is a 1 kilohertz frequency and 100 millivolts in amplitude. Now, frequency is how often something occurs, and we're talking about this horizontal axis here. So we can see there are two waveforms on here, because we start right here and we get right here, that's 1, and if we go again, that's 2. So that appears 2 times on here, and we're going to be able to figure out this time, which will give us the period of the waveform, and then get the reciprocal of that, which is the frequency. So we can see that this is indeed 1 kilohertz, and we can see that it's 100 millivolts as well. So here's what I'm going to ask you to do. I'm going to ask you to go to your SNP, and you type in SNIP, and with this snipping tool, you hit New, and you can just draw a box around whatever you want. And there we go. I have captured that image. I'm going to come up here and say Edit, Copy, and I'm going to go to Paint, P-A-I-N-T, and I'm going to paste that image. Now, I'm going to take this pencil up here, and I'm going to change my line size so it'll be pretty large. I'm going to use red. Now I'm going to show you the 100 millivolts, and this is how you're going to show me yours. And you can't use 1 kilohertz, and you can't use 100 millivolts. You'll have to adjust these knobs and then adjust your view. And I need it big. I don't need it tiny and small. I need it where you can see it and where we can see it. So you can change frequency, change amplitude, and then change this view up here. But I'm going to show you real easily. This is 100 millivolts, and we measure amplitude peak to peak. So here is our bottom peak, and here is our top peak. And if I count, there's 1, 2, 3, 4, 5 squares. Now each square is 20 millivolts per division. So if I come in here and I type 20, or put in 20 millivolts times 5, and I don't expect your writing to be any better than mine. It won't be where I can read it, but doesn't have to be perfect. And you can use this text feature. I'll use that on the next one. So with this red line I illustrated, this was the bottom. I counted 1, 2, 3, 4, 5. So of course the bottom's where we start. So this is 1, that's 2, that's 3, that's 4, and that's 5. So pretty easy on that one. So I'm going to change to blue now, And we're going to do the same thing, but we're going to do a little math here, because what we're getting is the period of this waveform. And a period is how long it takes for one cycle of this waveform to occur. So we start right here where this is, and we rise and we fall, and then we're right back to this same line right here. So that is one waveform right there, and we need to start right there where this little mark is, and we need to do the same thing. 1, 2, 3, 4, and 5. So that is 200 microseconds. Now 200 microseconds, I said I would use the text here. 200 microseconds is expressed as 0.123200. Because remember, the decimal point's here. If we go 1, 2, 3, that would be 0.2 milliseconds. And if we go 1, 2, 3, that would give us 200 microseconds. And if we say times 5, that will equal, and I'm going to bring up the calculator because I'm not going to pretend I could do that with all these zeros in my head. I should be able to, but it's early in the morning. So I'm going to do 0.0002 times 5 equals. That equals 0.001, or 0.001. And I can stretch that out. So that is the period. And I'm going to put period right here. Now the inverse of the period is frequency. So all we have to do is divide 1 by 0.001. So 1 divided by 0.001 equals 1,000. And 1,000 is the same as 1 kilohertz. So I'm going to come right here and say frequency equals 1,000 hertz or 1K hertz. So I want you to use a couple of different colors, just as I did. I want you to draw. I want you to give me a picture of a different frequency and amplitude on this particular device. And I want you just to send me a picture, submit me a picture of how you would measure that waveform here and how these values for each of these divisions, because we know each square represents 200 microseconds when we're going left to right, and each square equals 20 millivolts when we go top to bottom. And I want you to explain your waveform that same way. And when you're done, just come up here and say File, Save As, and call it Oscilloscope explanation. I already had it in there from another video I did. And there we go, just that simple. So do that for me, and that is all I need.